A freight train is waiting outside a yard. Another is crawling toward a junction. Containers are stacked beside cranes, locomotives are idling, and a main line that looks nearly empty from the highway is already spoken for. The obvious answer seems almost embarrassingly simple. If the railroad needs more capacity, build another track. America already has an enormous rail system. The Association of American Railroads says the freight network covers nearly 140,000 route miles. 6 Class I railroads account for 67% of freight rail mileage, while roughly 615 short-line railroads operate the balance. AAR also says rail carries around 40% of U.S. long-distance freight ton miles. So this is not a marginal industry running out of room in a forgotten corner of the economy. It is a national machine moving raw materials, finished goods, containers, vehicles, and agricultural products across distances where the physics of steel wheels on steel rail remain extremely powerful.
And railroads do build. They replace rail, add sidings, expand terminals, modernize signals, and reconstruct junctions. The question is not whether new track helps. It can. The real question is why another track does not always produce the simple, proportional increase in capacity that people expect. The answer begins with a change in perspective. A railroad is not one long conveyor belt. It is a chain of connected processes. A train can move quickly across open country and still lose time before it enters a terminal. A yard can sort cars efficiently and still have no departure slot. A new segment of rail can remove one conflict while delivering more traffic to the next one. Capacity belongs to the whole trip. Track is one part of it. Highways have trained us to picture capacity as lanes. When traffic becomes heavy, add a lane and create more room. Railroads tempt us into the same mental model because the infrastructure looks similar from above, one line beside another.
But trains do not enter and leave the system independently like cars. They are long, scheduled movements that need routes through switches, junctions, terminals, and territory used by other trains. The useful unit is not an empty piece of track. It is a complete path through a network at a workable time. For this documentary, think of freight capacity as a sequence of gates. The train must be assembled. It must receive a route. It must move across the main line. It may have to enter a terminal or classification yard. Cars or containers may need to be transferred. A crew must remain within federal duty rules. Maintenance must keep the physical route safe and available. Then the next train must do the same thing. This framework does not mean that one gate is always the national bottleneck. The limiting point changes by corridor, commodity, terminal, and time. It does mean that improving one gate cannot guarantee the same improvement at every other gate. Federal transportation reporting reflects part of this distinction. The Bureau of Transportation Statistics tracks train speed and terminal dwell as separate freight rail performance indicators. Speed measures movement on the road. Dwell measures time inside terminals. Neither metric, by itself, tells us which constraint dominates a particular shipment. Together, they remind us that a train moving across the map and a train being processed inside a terminal are in different operating phases. Imagine adding a second track to a busy approach. More trains may reach a yard with fewer conflicts on that approach. But if the yard cannot process those arrivals at the same rate, the line outside the yard has not disappeared. It has moved. Reverse the example, and the same lesson holds. A faster terminal cannot use its full potential if trains cannot reach it reliably. This is why rail capacity is less like widening a road and more like tuning a factory whose machines are spread across a continent. Every stage matters, and the slowest relevant stage can change from one movement to the next. Before a railroad can expand, it has to preserve the network it already owns. That requirement consumes money on a scale that is easy to miss because much of the work replaces something old with something that looks almost identical. BNSF's announced capital plan for 2024 offers a useful, carefully bounded example. The railroad described a total plan of $3.92 billion. Of that, $2.88 billion was assigned to maintenance of the core network. Just under $600 million was identified for expansion and efficiency projects. Those are BNSF's figures for 1 year, not a national formula. But the physical work behind them shows what maintaining a railroad means. The 2024 plan called for nearly 13,000 miles of track surfacing or undercutting, replacement of 365 miles of rail, and approximately 2.8 million ties. None of that produces a dramatic new line on a map. It keeps existing lines capable of carrying heavy trains safely. Rail wears, ties age, ballast loses its geometry. Drainage, bridges, switches, detectors, and signal systems all need inspection and renewal. If that work is deferred, nominal track mileage can remain unchanged while the quality and reliability of the route decline. The Surface Transportation Board provides another important boundary on how we read expansion data. For its annual Class 1 infrastructure reports, a significant project is one expected to cost at least $75 million over its lifetime. Reports are submitted in March and updated in September. Some carrier years in the STB table show no project to report under that rule. That does not mean the railroad made no investment. It does not mean every other dollar was maintenance. It means only that the carrier reported no project meeting that specific reporting threshold. This distinction matters because railroad investment is often discussed as if every dollar belongs in one of two boxes: expansion or neglect. Real capital plans contain renewal, compliance, resilience, efficiency projects, terminal work, and selected additions. A railroad can spend billions and still add only limited route mileage because preserving the existing machine comes first. According to AAR, freight railroads invested about $840 billion from 1980 through 2024, close to $1.4 trillion in 2024 dollars. AAR also says freight railroads averaged more than 18% of revenue on capital expenditures between 2014 and 2023, compared with about 3% for the average U.S. manufacturer. These are industry figures and comparisons, but they make one point difficult to dismiss. Freight rail is already a capital-intensive business. The mystery is not why railroads refuse to spend. It is why so much spending must go into preserving and selectively improving a system before a new line can even become the next question. From a distance, a classification yard looks like excess capacity. Dozens of parallel tracks spread across a wide area. Freight cars roll slowly between them. Locomotives move cuts of cars back and forth. Surely, if there is room anywhere in the system, it is here. But a yard is not a parking lot. It is a processing plant. Cars arrive in trains assembled somewhere else. Their destinations are not necessarily the same. The inbound train may need to be broken into groups. Those groups move through switches and are placed on different tracks. New outbound trains are assembled from cars that may have arrived at different times and from different directions. Locomotives, crews, and departure routes must then align. Intermodal terminals perform a different process with similar consequences. Containers arrive by train or truck. Cranes and other equipment lift them between rail cars, chassis, and storage positions. Every move uses space, equipment, and time. A train can be physically present at the terminal while its freight is still progressing through the handling system. This is why terminal dwell deserves its own metric. It is not simply slow mainline speed under another name. It measures a different stage of the trip. and it is why adding track outside a terminal can be useful without being sufficient. The added approach may allow more arrivals. The terminal still has to absorb and process them. The same caution works in the other direction. We should not declare that yards are always the dominant American rail constraint. The federal metrics do not establish that. Some corridors need more physical track. Some need a better junction. Some need terminal work. Some face several limits at once. The aerial view of a hump yard makes the system visible. Cars enter at one end, separate, roll into classification tracks, and later leave in new combinations. Each movement is small. Together, they determine whether a train that crossed several states can continue its trip or must remain inside the terminal. The lesson is not that yards are bad. The yard is the reason a rail network can connect many origins with many destinations. The lesson is that transportation capacity includes processing, not just motion. Nowhere is that network logic easier to see than Chicago.
CREATE, the public-private Chicago Region Environmental and Transportation Efficiency Program, says 1 in 4 U.S. freight trains passes through the Chicago region. Its overview describes about 500 freight trains and 800 passenger and commuter trains moving through the region each day. The important word is through. Chicago is not one railroad with one yard and one owner. It is a dense meeting point of freight routes, passenger services, commuter operations, roads, neighborhoods, bridges, and junctions. Trains do not merely need track, they need compatible paths through conflicts created by the geometry of the network. CREATE describes a $5.8 billion program containing 70 projects along 4 rail corridors. Its 2024 review also records a $291 million U.S. Department of Transportation grant for the 75th Street Corridor Improvement Project. Those figures show why the phrase, "build more track," can hide more than it reveals. In a place like Chicago, useful capacity may require a bridge, an underpass, a rebuilt junction, or a new connection between existing routes. CREATE describes projects that separate passenger and freight tracks with rail overpasses and underpasses, so trains can avoid crossing conflicts and delays. That is additional capacity, but it is not measured most honestly by asking how many miles of rail were added. The improvement comes from changing which movements conflict with one another. Picture 2 routes crossing at grade. A train on one route occupies the intersection, so a train on the other waits. Add another parallel track without changing the crossing, and the conflict remains. Lift one route over the other, and the 2 movements can occur independently. The project may affect a small area on the map, while changing how a much larger network operates. Chicago demonstrates a broader principle without proving a national average. In a mature rail network, some of the most valuable projects do not create a new long-distance route. They remove a conflict embedded inside the route that already exists. And that work is slow, expensive, and shared among institutions because the railroad is not building through empty land. It is rebuilding a live transport system, while freight trains, passenger trains, commuters, and neighborhoods continue to depend on it. Even a short new line can trigger a long chain of questions. Union Pacific sought federal authority under 49 U.S.C. 10901 for a 6-mile rail line in Maricopa County, Arizona. In November 2024, the Surface Transportation Board required corrected responses concerning ground disturbance and archaeological resources. In February 2026, the board issued a final environmental assessment before considering the transportation merits and the full record. This is one project, not a national average for permitting time, but it shows why 6 miles is not just 6 miles of steel. Ground disturbance, cultural resources, environmental review, and the transportation case become part of the project before the line can be judged as infrastructure.
Then there is geography. Caltrans planning material identifies a 2.5% railroad grade in the relevant Southern California freight corridor. That number is useful as a physical datum and nothing more. It does not, by itself, tell us a train's weight, locomotive arrangement, speed, or delay. Those operating consequences depend on facts not locked for this film. Still, the image matters. A railroad crossing a mountain pass must follow a route that terrain allows. Tunnels, bridges, curves, and grades are not abstract lines on a planning map. They are physical boundaries around every possible project.
Adding a parallel track through open terrain and rebuilding a constrained mountain corridor are both called expansion. They are not the same engineering job. A route through a pass may require work on structures, clearances, drainage, slopes, and signals before an added rail can deliver useful movement. This is why railroad expansion is usually specific. The question is rarely, how much track does America need? The practical question is, what exact constraint exists at this exact location, and what project changes it without creating a new problem somewhere else? Rail capacity is also governed by time carried inside the cab. Under federal law, a railroad generally may not require or allow a train employee to remain or go on duty for more than 12 consecutive hours. The law also defines how on-duty and deadhead time are counted, with exceptions and related rest rules governed by the complete statute. That is the safe factual boundary. This film will not claim how often crews reach the limit at a particular place, how relief is arranged, or how much capacity is lost. Those consequences require operational evidence we do not have. But the rule still reveals something essential about the system. A train is not only locomotives, cars, and a route. It is a movement conducted by people whose available duty time is finite and regulated. A plan that works on paper must also fit inside the legal and human operating day. This brings us back to the difference between physical and usable capacity. A piece of track may be clear, a locomotive may be available, a terminal may be ready. The movement still requires a qualified crew operating within the law. Conversely, a crew can be ready while the route or terminal is not. No single participant deserves to be turned into the villain of that interaction. Safety law, railroad operations, infrastructure, and scheduling are different parts of one system. The capacity question exists where they meet. After all these limits, it would be easy to swing too far and conclude that new track does not matter. That would be just as wrong as the original simple answer. BNSF's 2024 plan named double-track work in eastern Kansas. It named terminal and fueling improvements near Belen, New Mexico. It included expansion at the Cicero Intermodal Facility, development work for the Barstow International Gateway, and a track efficiency project in San Bernardino. The announcement did not provide a single national capacity multiplier, and we should not invent one. The projects are valuable because each is aimed at a defined part of the network: a mainline segment, a terminal, a fueling point, an intermodal facility, or a connection. BNSF also stated that it had invested nearly $2.6 billion in expansion projects during the 5 years preceding that 2024 announcement. Again, that is the railroad's own reported figure. It tells us that expansion is real and substantial even when maintenance receives the larger share of a particular annual plan. The useful distinction is not expansion versus no expansion. It is targeted expansion versus symbolic mileage. If trains lose time meeting on a specific corridor, additional track or a better siding arrangement may address that conflict. If container handling is the limit, cranes, terminal tracks, pavement, and transfer equipment may matter more. If routes cross at grade, separation can change the geometry. If the existing network is deteriorating, replacement work protects capacity that already exists.
All of those projects can be described as rail investment. Only some add route miles. The best measure of success is not how dramatic the construction looks. It is whether the project changes the constraint it was designed to address. So why can't America just build more railroad track? Because the word "just" removes the system from the question. It removes the billions spent maintaining rail, ties, ballast, bridges, switches, and signals already in service. It removes the terminal where cars must be classified or containers transferred. It removes the Chicago Junction where paths cross. It removes the environmental and archaeological review of a 6-mile proposal. It removes terrain. It removes the regulated human clock inside the cab. More track can absolutely help. Sometimes it is the right answer. But it creates useful capacity only when track is the constraint the project actually solves, and when the rest of the route can use what the new track provides. The scale of the existing investment explains why railroads search for precise interventions. According to AAR, the industry has invested hundreds of billions of dollars over decades and devotes a large share of revenue to capital expenditures. According to BNSF, its own 2024 plan placed far more money into core maintenance than into expansion and efficiency projects, while still funding named additions around the network. This is not evidence that railroads always make the right choice. It is not an argument that every delay is unavoidable. It is a reason to ask a better question than, why not lay more rail? Ask where the movement is constrained. Ask whether the problem is the main line, the terminal, the junction, the condition of the existing track, the project approval process, or the coordination of people and equipment. Then ask which investment changes that point without simply moving the queue. AAR says freight rail is on average 3 to 4 times more fuel efficient than trucking. That is an industry comparison and should be read as one. It helps explain why the capacity of this network matters to the country. Rail can move enormous freight, work over long distances with powerful physical efficiency. But efficiency does not make the network simple. From the air, a railroad is steel stretched across a continent. Up close, it is a sequence of decisions, handoffs, and constraints. The next mile of track may be transformative, or the transformative project may be a rebuilt switch, a terminal crane, a grade separation, a maintenance program, or a better path through infrastructure that already exists. The map shows mileage. Capacity lives in the connections.